Good afternoon, everyone. You all have to keep your cameras on. Yes or no? Class, why you are all without keeping your cameras on? Kyra? Yes, Vedika. I will give attendance only to those students who are with their cameras on. Is there any problem? Devshi. If you have any problem, let me know. Jami is saying, sir, my internet is unable. Okay. So those who have problem, okay, they can keep their cameras off. Others keep your cameras on. Okay, because I want to understand each one of you. Right. Okay. So we will start. This is our first lecture, right? Okay. You have first lecture with me. So we will start where Vidhi miss left. Last time you have done trigonometry with her. Something in trigonometry you learned. Okay. So we will explore what you have learned, and then we will add few more things to it. Okay. So what I will do, I will share my screen with you all, and then we will start. Yes. Now you all can see my screen. Okay. Our topic for today is trigonometry. We'll make it 100%. Okay. So trigonometry. Now, anyone tell me what is trigonometry? What we study in trigonometry? As you have already some idea of trigonometry. Anyone? What is trigonometry? And what we discuss here? Yes, Palak. Okay, Palak, you will tell me. Why you are going off? Okay, this is one idea, finding a known angle. Any other? Alison, what you say? Ah, Kiara.
Finding another side also.
Okay, Kiara, what you want to say?
So it's basically finding an unknown angle the side of a triangle.
Unknown angle. Yeah, okay. So is it necessary that triangle should be a right angle triangle, or for any triangle you can do that?
Any triangle.
For any triangle we can do that.
Sir, Vedika Kanwar won't be able to join today, and nor will Tanush Khanna.
Okay. I will request one of you to just keep an attendance and then
There is a
text me.
network issue where they live, so
Hmm.
the whole building.
Okay, fine. So we will start our journey to learn trigonometry from the right angle. Okay. Now trigonometry, as you all explained me, that it is a branch of mathematics where you try to get an unknown angle, okay, from the sides which are given to you. Advait Pandey, Advait, you are here? Advait, yeah, it's fine. So you can find unknown angle or you can find unknown side. Okay, there is some way by which we can find out either an unknown side provided I know the angle, or I will find angle provided I know the sides. Okay, so how we can do that? Let us one by one we will explore. So first what we do, first we understand six ratios. Actually here initially we should learn three ratios, but as there are six ratios, I will discuss all six ratios first with you all. Okay, so for that I will draw one right angle triangle. Now this is a right angle triangle in front of you, angle ABC. Uh, this right angle triangle is right angle at which vertex? Is it at B? At B, I have this right angle. Okay. Now, anyone tell me what is hypotenuse in this right angle triangle? Olivia, you tell me. Angle opposite to the 90 degree or side opposite to the 90 degree? Okay, which is that side here? Opposite to 90 degree, which side? You can see? Okay, side AC. Okay, simply side AC you can say. Okay, so AC is your hypotenuse, right? Now ABC, if angle B is 90 degree, I simply ignore B. So what is left AC? That AC we call hypotenuse. Okay. Now we are left with the two acute angles, angle A and C. Angle A and C both are acute angle. Is it possible to have two angles, right angle or an angle like here? Is it possible that any of A or C could be obtuse as well if angle B is 90 degree? So yes, sum of all three angles should be 180. Angle B is already 90 degree. So sum of A and C should be 90. And as sum of A and C should be 90. So A and C both are going to be less than 90 and therefore they are acute angles. So we have two acute angle, angle A and C. Now what I will do with respect to one acute angle, say angle A, we are going to define 6 ratios. Okay. As you already aware some of the ratios you have discussed with Vidhi ma'am. So this is a kind of revision for you all. So for angle A, what I am going to do, I am going to define 6 ratios. Now, before defining 6 ratios, what I will do, this side AB and side BC, I will define with respect to angle A. So for angle A, my side AB, okay, this side AB, for this angle A can be considered as adjacent side and side BC can be considered as opposite side. Okay. This naming is as far as angle A is concerned. If I move to angle C, then I have to reverse this nomenclature. Okay. AB is adjacent side. Adjacent side, why adjacent side? Because it is starting with A. So I will say this as a adjacent side and BC I will say as opposite side. Now for angle A, I will start defining the ratios. So the first ratio which we define is your sine. Actually, the full form is SINE, but in short, we write SIN and we read this as a sine. So, sine A. Now, sine A we define as it is side ratio of side opposite to this angle A, which is BC, to hypotenuse, which is AC, sine of angle A. Then we will define, so here in short I will say that this is opposite upon hypotenuse. Second, I will define cos. So the cos I will write as cos A, but this is the short form of cosine. This is the short form of what? Cosine. But simply we write as cos. So cos of angle A will be equal to adjacent side AB divided by AC. Okay. And this is adjacent upon hypotenuse, so I will say that. And the third ratio, I will define tan of angle. Now again, this tan is short form of tangent. So it is tangent, we say tan. So tan of angle A will be equal to opposite side BC upon adjacent side AB. Okay. So opposite upon adjacent. So no need to be confused. Simply what we have done in a right angle triangle, we have defined ratios of the two sides as sine, cos and tan. Now when we are defining sine, so it is a ratio of opposite side divided by hypotenuse. Cos is adjacent divided by hypotenuse. Tan is opposite divided by adjacent. Any doubt so far? Is these three ratios clear? Let me know if I am going
Yes,
too slow. Okay, I'm not going fast, I'm going slow. Okay, so these are the three ratios. Is any other ratio possible for these sides? There are three sides, three ratios I defined. Is any other ratio possible? Can I define some other ratio?
define what though?
Okay, let us see. Can I define a ratio in which instead of getting opposite upon hypotenuse, I get hypotenuse upon opposite,
Yeah.
right? So I can define. Now this hypotenuse of divided by opposite is nothing but it is your reciprocal of your sine, right? And this reciprocal of your sine, what we do, we give another name to this, and that is cosec. Okay. Now this may be little extra, but no worry, as these are there. So we will discuss once whether we will use it or not, but better to discuss. So I can reverse each and every ratio what I had discussed here. For cos, I discussed A divided by H adjacent upon hypotenuse. So 1 divided by cos A can be written as hypotenuse upon adjacent, and this is called as sec of angle. And similarly, 1 upon tangent of angle A, tan of angle A, can be considered as adjacent upon opposite, and therefore it is one other ratio that we call cot. Now again, these are all short forms. If you see long forms, this cosec is actually cosecant, sec A is secant, and cot is cotangent. Now these three ratios are of not much in use to us right now, but they are there. So as they are there, initially let us discuss them as well. Okay. So these three ratios, they are again fine. So with three sides, I can define six ratios related to a given angle. So for angle A, I defined six ratios: sine, cos, tan. Okay, they are important for us. So we remember what is sine. Sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is your opposite upon adjacent. Now you must also have heard something called so, ka, toa. Yes or no? This is initially to learn all these ratios. Okay. But as you start doing the problems in trigonometry, all these ratios you will by heart yourself. Okay. Your sine is opposite upon hypotenuse. So we write this as SOH. SOH, sine opposite upon hypotenuse. Cos adjacent upon hypotenuse. Tan is opposite upon adjacent. Okay. Similarly, we can define ratios for angle C as well. Yes or no? Okay, now I will give you one problem. Any problem, any doubt? Any one of you?
No,
No,
sir.
perfect. Okay, fine. Now let us discuss one problem. Here I will draw one triangle. Now triangle is something like this. Okay, and its naming is also I will use something say Q, Z, N. Okay, and I will make this angle n as a right angle, and I will write this side as 5 and this side as 3. Okay, now you have to tell me first what is sine of angle q. Okay, sine of angle q.
Unknown angle though.
Unknown angle?
Yeah,
Unknown angle or unknown side?
that is Q, right?
Here we have three angles, angle q, n and z.
Yeah.
Angle q and z, they are acute angle. Angle n is right angle. I know the length of qn, I know the length of qz. Okay, I don't know the length of zn. Can there a method by which I can find this nz as well?
Yes.
What is that?
You could find angle Q first, and then sum of all angles add up to 180 degrees. So
No, no,
that
no,
is
no, no.
why-
I'm
Pythagoras theorem in this?
yes. Yep.
Oh.
Right now, Pythagoras theorem you will use and you will find nz first. There is no way you find that angle q right now. Okay, how I find angle q? Okay, you will say that trigonometry, I will use trigonometry, but that is okay. We have not discussed yet. Okay, so yes, you have to first find nz. Now calculate and let me know what is nz, value of nz. How you are using Pythagoras theorem?
A square plus b square equals to c square. So 5. So c is equals to square root. No, wait. A square plus b square equals to c square.
Okay, huh. So here what is A, what is B, what is C?
We can take A as 3, B we can keep unknown, and C will take as 5.
All right, okay. So C is your hypotenuse. So C is 5. Yeah, then do the calculation and let me know what is NZ. Do the calculation and let me know what is NZ.
It's 4.
Yeah, very good. It's 4. Simple. Right? So this 5 square, here you have 3 square, here you have Zn unknown square. So this Zn square will be 5 square minus 3 square. You will get 25 minus 9, 16. Then you will get 4. Okay. Now what is sine q? What is sine q?
Sine q is unknown. Like, it's
And
sine q theta.
now we have all the three sides. Huh? Sine q. Can I say it? Sine q is nz upon qz,
Yeah.
and nz is 4, qz is 5. So sine q is 4 divided by 5, right? Okay. Now I will ask. Sorry. Okay. Now I will ask Alison. Okay, Alison. Okay, you are there. Now tell me what is tan of angle Q.
Tan O upon H. O upon A, sorry.
So here.
Tan Q, 1 second, opposite, which is 1 second. 4
Yeah.
upon 3.
4 upon 3. Okay, wonderful. So tan Q here is 4 upon 3. Right.
1.33.
Which is equals to, yeah, 1.33. Fine, fine. Okay. Now to whom I will ask, just a minute. I will see who are there. All boys, they have mass bunk today's lecture.
Sorry, only have 3 boys in our class. 3 boys.
Acha, but those 3 boys are like 30 boys. Yes?
Sir, I'm telling you, during the prelims, you should cut 50 marks from their papers each. All 3 boys. That's awesome.
50 marks. Okay. Fine.
So best board में पेपर देने के लिए allow मत करो युवराज. उसको तो specially, please.
ऐसा क्या कर दिया? What he has done?
बहुत. That's more than her in the paper.
Okay. Fine. Okay, Jamie, you tell me. Now If I'm not calling your name correctly, then let me know your correct name. Sometime it may possible that
Jamie.
it's Jamie only, na? Jamie. Okay, Jamie. Fine. So you tell me sine Z. What is sine Z? Here. Sine Z.
So sine Z would be Qn upon QZ.
Okay, so 3 upon 5, right? 3 upon 5. So sine Z is 3 upon 5. Okay.
Sir, I have a question.
Yeah, tell me.
How do you know, like, what number is which sign? Like, sine Z can be 4 or 5, right?
No, 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 no. Sine Z. This is your angle Z. Okay. We define sine as opposite upon hypotenuse. Na? Opposite of what? Opposite of the angle which I am considering. So which side is opposite to angle Z?
3.
3 only, na? The numerator is going to be 3 and which is hypotenuse? 5. Hypotenuse is QZ. It is always fixed.
Sine is okay.
Okay. So here initially what I said that with respect to some angle we are talking about. With
Right.
respect to some angle, right? Okay. Okay. Can anyone tell me what is sine n?
Can I try?
Sine n, yes, try.
Sine n would be 5 upon pi upon 4.
Why pi upon 4? Its sine is always opposite upon hypotenuse. What is hypotenuse here?
So opposite is 5, but then how do you guess what is hypotenuse?
The hypotenuse is 5, I think.
The hypotenuse is 5, yes. Hypotenuse is always opposite to 90
To 90
degrees.
degrees.
Yeah, so both can be 5. Okay.
So what we get? 1. Okay.
Oh,
Sine 90 is 1. Okay. Actually, for this 0 degree and 90 degree, there are two special angles that we will discuss later on. But now, so far, idea of sine, cos, and tan is little bit clear. Actually, we are finding all these for acute angles. Okay, now for just I discussed for 90 degree as well. But we are basically finding these trigonometric ratios for sine, cos, and tan. Sorry, for acute angle. Okay. Now I will discuss one interesting thing. Suppose I have an isosceles right angle triangle. Now, what you understand by isosceles right angle triangle?
Two angles are the same.
Same. These angles are the
Okay, and as well, it is a right angle triangle. Okay, so I will take a right angle triangle ABC, in which these two angles are same, AB and AC same, angle A and C same. Okay, so is their sides also going to be same? These two sides.
Yes, sir, because
Okay.
if the angle is same, then the side should also be.
Okay. Okay. Let us consider this side AB as X and side BC also as X. Now tell me what is AC.
oh, AC, the angles, right?
No, no, no. I am talking about AC side.
Oh, the side.
Yes. Again, that Pythagoras theorem you will use.
Square plus
AC square is going to be equal to X square plus X square. That is 2 times X square. So if I find AC, which is square root of this 2 and square root of that X square, which is X, right? Yes or no?
Yes, sir.
Okay. Now tell me here, if I find sine of angle A, what I will get? Sine of angle A.
X upon square root of 2.
X divided by root 2 X. So this X will cancel and I will get 1 upon root 2. Or if you are using your calculator, you will get root 2 divided by 2 there. Yes, 1 upon root 2 in calculator, it is shown
Yes.
like root 2 upon 2. Okay. Why it is shown like this? Hmm? Why it is shown like this?
Not.
Acha. Okay, tell me what is sine A we have understood. What is sine C? Tell me what will be the value of sine C?
It would be the same. It would be x upon root 2x.
Okay, so finally it is going to be same 1 upon root 2. Okay. So this angle A and angle C, why their values came same? Because these two angles are same. I can say sine 45 is equals to 1 upon root 2. Yes or no? Sine 45 is 1 upon root 2. Yes. Okay. Now suppose here I took one triangle. Now suppose I enlarge this particular triangle. I take a big triangle. But again this is an isosceles triangle only. Okay. Say PQR. And here angle P and R are 45 degree. And in this big triangle, if I find sine 45, so is the ratio remains same 1 upon root 2 or it will change?
It remains the same.
It remains the same, right? So from this one thing I will conclude that the value of these ratios, the value of these ratios depend on the angle only. Okay, it does not depend on how big or how small your triangle is. It only depend on the angle. So if it's 45 degree, so sine 45 degree is going to be 1 upon root 2. Okay, so for all kind of triangle in which you have one acute angle 45 degree, you will get sine 45 as 1 upon root 2. Okay. So from this, can I conclude that for different angles, there are different fixed ratios. Like for 45 degree, I have a fixed ratio of 1 upon root 2. So if the angle is 30 degree, then that is going to be a fixed value. Right? Little confused? Or you
So
understood?
could you repeat what you just said? I don't think I got it.
Yeah, what I said that like this for 45 degree, for 45 degree, what we understand that whether my triangle is small or big, okay, it is always going to be 1 divided by root 2. So the ratio's value 1 upon root 2, this is depend on what angle I have considered. I have considered 45 degree. If I consider some other angle, so then this ratio will change.
Yeah.
Yeah, this ratio will change. But whatever value I get, like for 30 degree, if I take a triangle in which one acute angle is 30 degree, so that is actually called triangle something like this. Now in this triangle, this angle A is 30 degree, this angle B is 90 degree. What is this angle C? Angle C, angle C is 60 degree. Yes or no? Yes. Now if hypotenuse, practically if I draw this hypotenuse of length 1, then this length AB is going to be half of the length, and then this length BC is going to be root 3 by 2. Okay, this is practically if we draw a triangle with 30, 60, 90, and we can prove this as well. Analytically also there is a proof available that if your this hypotenuse is 1, then this side will become 1 by 2, this side will become root 3 by 2. Now here if I find sine 30, so sine 30, what I will get? Sine 30. Oh no, I have made a little mistake. Okay, this side is 1 by 2. This side is 1 by 2 and this side is root 3 by 2. Now if I find sine 30, what I will get?
Okay.
I will get 1 by 2. right? If I change this triangle, I will increase this triangle. Say like this, I increase this triangle. Okay. I make a similar triangle A, P and Q. So in this triangle APQ also, the ratio of the sine 30, which is now, it will be PQ divided by AQ. This ratio is going to be 1 by 2 only. It is going to be half. Okay. So for given angle, the ratio is fixed. So if 30 degree, then sine 30 degree is always half, right? So if for a given angle the ratio is fixed, why can't we use calculator? So we use function, we put all these things in calculator and we use calculator. So now using calculator, you can tell me what is sine 30 degree, you can tell me what is sine 60 degree, you can tell me what is sine 24 degree and all, everything. Bring your calculators everyone and see there are functions called sine, cos, tan. So in your scientific calculator, okay, I have one in my hand. You can find sine, cos and tan. Are you able to see it?
Yes, sir.
Yes, okay.
Yes, sir.
Now use your calculator and tell me what is the value of sine 30 degree in your calculator. Sine 30. Press sine 30 and see what result you are getting.
1 by 2.
Everyone getting 1 by 2 only or someone getting some other answer as well? It's 1 by 2 only, right? So with the help of calculator, now I will find the trigonometric ratios for a given angle. Okay, and with the help of this, I can find out unknown side. Now let us see one example. Okay, I have again a right angle triangle. Now in this right angle triangle, here the angle is 15 degree, and here this hypotenuse is of length 4. Okay, say 4 centimeter. Okay, ABC. Okay. Now, using your calculator, you have to find out what is the length of AB and what is the length of BC. Okay. Using calculator, you can find out AB and BC. Try and let me know if you are able to find the length of AB and BC.
Sir, is AB 4.14?
AB 4. How it is more than hypotenuse? Hypotenuse is the longest side.
1.035.
Whose value you are telling me?
Of CB.
BC. Yeah. Yeah. Tell me. 1.35.
1.35.
And what AB?
035, sorry.
1.035. Okay. And what is AB?
I didn't check that yet.
Okay. Now let us see how actually you got this 1.035. Actually, you might have used sine of 15 degree,
Yes, I used
and
sine
sine of 15 degree is your BC, which is unknown, divided by AC, whose value is 4. So simply you say that BC is equals to 4 times sine 15, and as this sine 15 I can get from calculator, so I will use calculator and I will say that 4 times
Yeah,
sine 15. Sine 15, and therefore I will get answer 1.035. Very good, 1.035. Similarly, to get BC, to get AB, now I can use cos 15 degree. If I get cos 15 degree, it is AB divided by AC. So I will say that AB is equals to AC is 4 times cos 15 and 4 times
3.83.
cos 15. Okay. Yeah, its value is 3.86. 3.86 centimeter, whatever unit we are dealing with. Okay. So like this, we can find out unknown sides. Now angle, here we are measuring angle in degree, but there is another system of measuring angle as well. Do you know? Any one of you know? As distance I can measure in feet as well as in meter. Similarly, the angles I can measure in different units. Do you have any idea? No? Okay. Actually, on your calculator, if you press shift and mode, you press shift and mode, then you will find some functions like degree, radian, gradient. Degree is DEG, radian is RAD, gradient is GRA. Actually, they are different units to measure the angle. We can measure angle in gradient also. We can measure angle in degree also. Like suppose you keep your mobile on radian mode. For radian mode, what you will do? Here in my calculator, what I have in this, if I press 4, my calculator will go in radian mode. Okay. So similarly, there will be some other number for you. Okay. Now, if I go in radian mode, I won't recognize that this is in radian mode because this looks similar. But now when I find sine 30, when I find sine 30, okay, it will not give me 0.5. It is giving me minus 0.988. Is the same thing is happening with you all?
Yes, sir.
Right? Okay. So what this suggests that you also have to check your mode of the calculator, whether your calculator is dealing in degree mode or it is dealing in radian mode, right? Uh, by mistake, if your friend has made your calculator in radian mode and you are solving the problem by considering that, okay, I am typing sine 15 and it is giving me the value of sine 15, you will be surprised that your answer is not correct. Okay, because your mode is not correct. So where, how you understand that this mode is radian or degree? Is there any way you will understand that this is degree or radian?
On the top, it has a D or a G or an R.
Very good. So always whenever there is a calculation related with angle, okay, see on your calculator that D is written over there. Okay, D is written over there, and then you use angle. Otherwise, you will get some incorrect result. And if you are like too much aware of the values, then you can figure out that, okay, I am getting some wrong answer, or understand. Okay. Now I think for today we can stop here. I will just take your attendance and then you all can leave. And if you have any doubt, you can ask me so far whatever we have done. Anyone have any doubt? Let me know.
No doubt, sir.
No doubt. Okay.
No, sir.
We have grade A. Okay, I'm just calling the names one by one. Let me know. Alison,
I'm here.
yeah, present. Then something Avni, AVNIE, Avni. It is
She
Avni
joined
only?
and then she got
She was
locked up.
here, but now she's
She
Acha.
was there.
Okay. Now Dev Bhuta, absent. Devshi,
present.
present. Palak,
Present. No, Falak is not here.
Jemi.
Sir,
Jemi is
Palak
present.
Wait, are you
No,
saying
sir.
F for
Ah.
Falak or P for Palak?
P for Palak. It is Falak Khan. Falak Khan. Ah.
No, Palak is
Internet
there.
issues.
Ah.
Yeah.
Palak was here.
Acha, Jayansh. Okay,
Jayansh
fine,
wasn't
fine,
here.
fine. I will consider internet problem. I will mark the present. Okay, Jayansh,
Not here.
not here. Kiara,
Sir, my name is
Present.
Kyra.
Kaira, Acha, Kaira, 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 present. Olivia, present.
present, sir.
Palak, present. Then Tinel D'Souza,
Chanel was there. She got logged out in the same way. She was there. She was
Chanel.
asking questions.
Chanel, and Tanishq.
Tanishq and Vedika Kanwar have internet issues.
Acha, okay.
Their whole building.
Okay.
I think.
Vedika. Vedika,
Yes, sir.
okay, present. There are two Vedika, na?
have
Vedika Vararkar is here,
Barabar, yes.
and Vedika Kanwar is not here.
And there was another Vedika in the other class.
In other class? Acha, we have three Vedika. Oh,
Yeah.
and Yuvraj. Yuvraj is absent.
Absent, sir.
Ah.
Who is sorry, they absent, please.
Why,
Okay.
sir, we have three Vedikas.
Huh?
Sir, we have three Vedikas. We have Palak. We have a Tanishq who's a girl.
Tanishq is a girl.
No, we have a Tanishq and Tanishka.
Acha, we have Tanishq and Tanishka.
And that
Okay.
Tanishq is a girl.
Okay.
Dev and Devashi. I'm so sorry, Devashi, but
Okay.
Dev and Devashi.
Okay. But
Yeah,
Yuvraj, you are
Kyra,
too much
Kiara.
absent.
We don't have a
Acha.
Kiara, but you can mistake her name as
No,
Kiara.
we don't have a
Ah, Kyra. We have Kyra.
We have Kiara, sir.
Yeah.
We don't have a Kyra, we have a Kiara.
We have a Kiara. Acha, we have a.
She doesn't like her name. That's why she asks everyone to call her Kyra, but her name is actually Kiara.
Yes.
Yeah.
So she's a con artist.
Yeah.
Okay. Fine. ठीक है. Chalo, no problem. So we can stop here, and I will see you all in the next class. Right? We will see something interesting. Yeah. Bye bye.